program for the next 20 minutes, as much as I can get through, is first of all to prove three things. First of all, consciousness is quantum characteristics, and some of those elements already have been discussed in previous presentations, so I can skip on them quickly. The second element, that consciousness is the same characteristic and general structure across all levels of animals or organisms. And the third element is that phenomenal consciousness, or what's called hard problem, arises from retrocausality, and I'm proposing an evolutionary mechanism that can describe how it arose. So I'm going to try and cover that in the time that we have. And just a little story how we came to be doing this today. I put in the abstract for this conference about 4 or 5 months ago. It's about the same time my partner and myself went to the market and bought some scallops. We were living in Paris at the time. And a friend showed us that to make scallops you have to open them up, and as they're alive, then you cut them and put some lemon. It's really delicious. I've never done it. So I took a scallop and I put a knife on it and started to open it. And it didn't like it because it's still alive and it really wanted to close itself. And I had this really, really bad feeling in my stomach, and I thought, wow, this thing is conscious. I can't kill it. So I was a chicken. I asked my partner to do that for me. But if you want to summarize what I'm going to talk about today, I'm going to answer the question, are scallops conscious? And at the end, I'll share my conclusion about that, because this is really an outcome from the discussion that we're going to have. And just a very brief background. I came to this work through working about 5 or 6 years ago with a guy called Jacques Sarfati. Jacques Sarfati is a bona fide made genius physicist who is in his 80s. He claims to be the inspiration to the main professor in the Back to the Future films. And he basically, what's really great about him is that he's got amazing intuition about physics. He's not so good in the rigor, but his intuition, I think, is beyond anyone I've ever met. And he put together a theory called post-quantum mechanics. I'm not going to go into the details or any of the equations or none of those things. What I'm going to do is I'm going to go through all of that, and I'm just going to go to the conclusions. The conclusions say eventually that quantum systems can be described when we use what's known as, you also mentioned it, the two-state vector formalism. That is the idea that the present is a mix of the past and the future. Can be described using something called beebles with them. A beeble is an idea that was developed by Bell from the Bell inequality, and it's the idea that you have a kind of a variable in the system that is actually classical in nature. And most quantum systems don't have any classical elements in them. Either a system is fully classical or fully quantum, but there's a way, according to this, the few articles that were developed, to mix that backwards and forward forces with classical system. For the first time, you can actually work together with those things. The second element is that this may lead to breaking of what's known as the Born rule. The Born rule was mentioned in a few lectures, actually yesterday, is the fact that quantum systems go to either state A or state B as a function of the size of the parameters in front of the wave. I don't want to go into the details. And the third element is this connects to something called entanglement signaling. In plain language, it may mean that in certain cases you can send information from the future to the present. And this is, again, relates to the discriminant precondition. So all of those things together create a kind of a framework that says, it might be possible in the future to send signals where we are now, and it's going to be possible to understand them in terms of physics. This is the end of the physics for this, so don't worry. So his insight was that when you have a system, quantum system, it's got this wave function. The wave function is kind of spreading around the particle, and it can go in different places. But when we look at wave functions, we normally ignore what is the impact of the particle on its own wave. And I'll give you an analogy. When we look at, for example, the sun as a star, we all know that if you want to try and take a picture of general relativity, you take this picture of a kind of a conus that comes down here, and the sun is in the bottom of this gravity well. And the sun affects its own gravity and everything around it. In quantum physics, we don't have that element of the way something reacts on itself. And the claim that Jack came with is, he says this is a new force, this actually doesn't really get into the existing kind of quantum physics, and he says this is what causes consciousness as we know it. And that was our starting point. My end is a bit different, but I just wanted to set the picture for that and go to the kind of, I think, more interesting parts. The second element is, what is the challenge with existing current theories of consciousness, which is based on quantum physics? And the other candidate is PQM, which is this kind of variant that Fatih is talking about. But there's a problem with all of those theories. The problem is that they're very low level. They describe really the bottom of the chain because they look at subatomic particles, and it's very hard to imagine now what happens between two molecules translates to what happens to me if I'm hungry and I want to have a steak rather than a salad. And the second level is that, the second issue is that it's very hard to think how those very, very fundamental ideas about kind of subatomic particles can fit into a higher theory of the brain, any of the functional theories that actually describe what causes consciousness and whether it's integrated information theory or other theories. So those kind of problems, even though it makes quantum theory very interesting as a candidate, makes it very challenging to think about them as, at this stage, as a realistic solution to the hard problem. And so what I kind of try to do in this work is to find a way around that and integrate a quantum approach with a high-level theory and show what that means and what you get when you do that. So the first element is, first of all, consciousness. Does consciousness have a quantum element? This is something that was mentioned by Stuart, and he actually showed, I think, even showed this picture. This is an experiment by Benjamin Libet. It was done in 1979. What Libet has shown is that in certain situations, we have two types of input that you can get. You can basically touch someone on the hand. When you touch them on the hand, within 20 to 30 milliseconds, they say, oh, someone's touched me. Or for patients that have electrodes in the brain, you can touch the area in the brain where the sensation of being touched in the hand goes to. But when you do that, it takes about 500 milliseconds for the activating potential to kind of grow until the person says, oh, someone's touching me in the hand. So we have a discrepancy. If you physically touch someone, they feel it straight away. But if you kind of stimulate their brains, it takes them half a second to get that sensation of being touched. And they're all interesting, so what? A really interesting element happens that in some cases, if you combine the two, which means you touch someone on the hand, but then afterwards you start to actually interfere with the signal in the head, the person doesn't report that it's being touched in the hand. Somehow, something that happens after the event, if you do it fast enough, reduces, takes away that reporting. It's as if the system kind of goes back in time, and because there was no time for the signal to build up, the effect never happened. And that's a very quantum effect, and it's similar to a class of experiments called delayed choice experiments, which basically beat all intuition and makes everyone think whether the world we're in is actually real. And Libet called this 500 milliseconds, that increase in potential neural adequacy. And we're going to come back to that because this is part of the keys for understanding what's going on in the brain, in my view. And then the second element, which I'm going to spend a lot of time on it because it was touched here, is the element of precognition. And then the element of remote viewing. I've personally met people, I met Keith Green and Hal Partner, they're the people who were in charge of the CIA Stargate program, which was the remote viewing program in the CIA. They told me about their experiments. They actually, they're the one that tested people like Uri Geller to see whether it's real or not, and lots of similar things. And it seems beyond doubt, in my view at least, that precognition and remote viewing is a real phenomenon. There's a little ghost there. It's not because I had ghost experiences, but because I had a few personal experiences in my life, which everyone wants I can show for a cocktail, which to me show beyond doubt that remote sensing and precognition are 100% part of our universe and our reality. And so, based on all this kind of what I call curated evidence, because there's been a lot of articles that put those things together, and actually those articles were so hated by the scientific community that the statistical analysis that was done to describe them was scrutinized to such an extent that someone's made the comment that if any article in social sciences was scrutinized that way, there would be no social science. So I think there's no doubt that this thing is a real phenomenon. So I think only quantum theory can really support the idea that those effects are there. I'm just making a quick point, I'm not going to go into it. I don't personally believe that non-computability by itself is a strong enough candidate to support quantum theory, because I can think of other mechanisms, in the form of mathematics like presented by Roger Penrose. I can think of certain situations where other things can solve problems without having to resort to non-computability. So I think by itself, it's not a strong enough candidate, but altogether, I think definitely we're seeing quantum effects in the brain. And so the next element is that this is really nice, but I already said in the beginning, quantum by itself doesn't help us, because we can't explain why we like coffee or tea, because the molecule in my brain wants to split this way. And so in order to combine quantum theory with a theory of consciousness, we want to go to this next level. The next level is look at the theory of consciousness that I believe makes sense, and because of certain characteristics can be combined with the quantum theory to give like a whole picture. And in the process, we're going to show, based on that theory, that most organisms have the same structure in terms of consciousness. What I'm going to use, the theory I'm going to use is essentially the predictive processing theory, which is developed by Friston. And it's a special version of that, which was described by Mark Solms. I first seen it when I read the book The Heat and Spring. If you haven't read it and you like anything to do with consciousness, read it. It's a great book. And it gave me some real insight that I haven't read anywhere else in this field. In 30 seconds, what they're saying is, the idea is that the brain predicts the output. So in a sense, we're inside this kind of blanket. The blanket receives input from the world. We have models inside that try and predict what we think the world is based on those inputs. And it's a continuous structure or process of building up models, which I'll show very briefly in the next slide. The important thing really from a point of view of Solms, he says he believes that consciousness is located in a few cubic millimeters in here. This is the reticular activating system. It's a structure in the bottom of the brain. There's a lot of reasons in the book why I believe that's the case. The reason why I like this is because he shows that this is an area of a few cubic millimeters, which means there's a very small area in the brain that he believes, based on his ideas, that is the source of consciousness. The other thing which he really says, which is very important, he says we're conscious because we feel. Consciousness is actually what provides affect in the brain, as opposed to computation. So computation is there, but the important thing is that consciousness provides the background for the computation. And the really biggest insight that he had is that we become conscious when our predictions are not precise anymore. So when we're doing something and suddenly a model of the world isn't precise, we have to make it more precise. And that moment of making it more precise is the moment of consciousness, according to that theory. There's a lot of anecdotes you can think from your normal life when you have, like, for example, visual illusions and things like that, where you think, oh, this doesn't make sense. There's an extra level that you go up in your mind in order to try and understand that. Now he says it's a much more basic thing, based on the theories which is presented in the book. I'm not going to go into it now, we have no time. And so this is the system, and this is the key. In our mind, we have two systems. We have an autonomic system, which takes all the sensory inputs and gets it to the bottom of the brain. And you saw, by the way, in one of the talks earlier, when he talked about the monkey that was blind, he showed that the optical nerve divides into two. One goes to the autonomic system, and the other one goes into the cerebellum. And in the specific case of that monkey, the top one was cut. But the monkey could still see, it just couldn't process it. And this is really, so the bottom one goes to the autonomic system, and the top one goes to the cerebellum, to our cortex. And the consciousness sits in that point where those two meet. And why is it important? Because this system, what it does, if someone, for example, puts something in your visual field and touches you, it takes your attention quickly, but also it starts to move your body so that you can quickly kind of move towards it. And so it gives you the initial kind of impetus towards kind of responding to something without really understanding it. This system understands what you're seeing and gives you a strategy. This is not what it is, this is what I need to do about it. Quickly, I'm going to do more than 2 minutes because there's started very late because other people were late. So you have to, those that don't like it are happy to move away. Basically, the other insight is I try to think, what is the information content of consciousness? How much, and we kind of think that we see a very, very rich world. We see lots of things, and there's a lot of things in the consciousness. But when people measure consciousness, the information content is really low. We can process 60 bits per second. 60 bits, if you think about it, compared to the information that we see around us in the room, is a very, very low amount of information. We can remember 4 chunks of memory, maybe average 40 bits of info at a time, and visually, people say that we see about 11 bits of information to try and understand what we see at any given time. If you think about it then, because 60 bits, 60 times per second is quite a low frequency compared to what's going in the brain, consciousness doesn't really keep a lot of information in it. It's there, but it doesn't really take a lot in. And that gives us a model of consciousness. There's conscious experience and conscious content. Conscious content is what I see. I see the curved ceiling, I see you, I see the walls. The conscious experience is what am I focusing, and I'm aware of it every given time. And this creates like a, if you want to call it like a radar model, where the conscious experience is very, very narrow, but it basically scans your insight or inputs or senses coming in all the time, and it builds a picture. So it's a very narrow beam, like a radar that goes around and builds a picture, but at any point it's very, very narrow. The second element, which answers the question of complexity in animals, you can think about it like a simple terminal which is connected to a computer. So your consciousness is your terminal, and now your computer can be an old IBM PC or it can be a supercomputer. Your interface will be the same, but you're going to get different data from that. And the proposal I have is that consciousness is the same. Consciousness is very narrow, whether you are a monkey or a person, because a person's consciousness is got a very, very little width of information. So in animals, information content can't be much lower than a person. We're very close to the bottom. What's different is that the radar screen is much smaller. The radar screen is what our brain can feed us and what our senses can feed us. So we have the same kind of like laser light, but we have small landscape versus big landscape. And that's the difference in the content of consciousness between animals and people, for example, or lower animals. And so we get into the last phase. Where does phenomenal consciousness come from? So my proposal, based on especially this idea of limit, where information comes backward, and lots of other elements in the brain that show that time doesn't go in the same direction in the brain. There's a lot of time-binding elements in the brain and lots of those examples around, is that retrocausality is the primitive of consciousness in the brain. What actually makes us conscious is that click of going a bit backwards in time in order to integrate information. And there's a rationale. The rationale is that it seems to be crucial in integrating senses, like what we saw in Lieber's experiment. And also it's going to provide an evolutionary advantage because, and we're going to talk very briefly about evolution, and the way to think about it, if I'm walking in the bush and a saber-toothed tiger wants to attack me, if I have to wait half a second until I recognize it's a tiger and it's not a pretty tree, I'm going to be dead. So that ability to integrate information backwards to an earlier point in time provides an obvious evolutionary advantage. And what is the mechanism that creates a conscious event? First of all, we have sensory input, which the second one is we have this build-up of 500 milliseconds of this deep neural latency. And what my contention is that what it does, this actually creates the content of what we call qualias, which are the elements in the brain that have meaning for us. So the more advanced you are as an animal, you have more stuff coming in, you have more memory, more models. It takes more time to make sense of what you see because you have a bigger vocabulary to choose from. It takes about 500 milliseconds for people. When this kind of builds up, then we have a collapse event. And that collapse event occurs, and we have half a second retrocausal movement into the area where we actually sense it, and this is where we have the kind of conscious event. I'm not going to go into what I'm saying with measurements and all of those things. I'm happy to discuss it later. The big difference between that and the Penrose theory and all the existing theories is all existing theories say when collapse happens we have consciousness. I'm saying actually it doesn't work this way because if that would be the case we can't have information backwards. collapse happens here, and a weak measurement is a form of influence on the system without creating a collapse. But this allows us to have a mechanism that gets information a bit backwards. And this actually explains also experimental results. And there are two types of consciousness. Sensory consciousness is what happens from the bottom, and reflective is what happens from the top, from the cortex, which has to do with process consciousness. This is just a general model. Let's just combine them all together. I don't have time to go into this. And this is really what I think is sweet about the whole thing. So why are we conscious? And why did evolution make us conscious? And I think this kind of explains it. Initially, when you have a low-level animal, it's got all sensory input coming in, but it's got very few neurons, which they call as a sensory associative structure, which is the neurons that actually take the different senses and try and do something with them. So if you look at a worm, it's going to feel things, but nothing will process those ganglions, nothing going to process those inputs. And so we have essentially the time it takes the processing of what we call the new higher level neurons, and the very, very short time it takes the senses to come in. And the higher level neurons are always going to take more time because the lower level neurons just come in and go tick, and they get us squared away at 30 milliseconds with people. The higher level neurons are the ones that actually try and look for understanding and information before they do the processing. So this number, there's always some delta between what we actually feel straight away and what it takes to process. That's the gap. And now from an evolutionary point of view, if that gap is very short, it makes no difference. If it takes 1 or 2 extra milliseconds, it's not going to kill you. But if it takes half a second, it will kill you. And so there's a certain gap, call it the T evolutionary, that says above that gap, if you actually start to get delayed, it's going to have negative survival benefits for you because it takes too long for you to understand what's happening around you. And so you have two chances, as a system, you have two alternatives. Either stop growing your central nervous system, or select or develop this retrocausal mechanism that allows you to grow. And this is why, this is qualia, as I mentioned before, happens when we have retrocausality. And this is why qualia occurs. Qualia occurs in the brain because it creates the mechanism that allows us to go a bit backwards and understand the world around us and survive as organisms. And in the simplest way, there's life, there's what we call as proto-consciousness, which, by the way, someone mentioned plants earlier. I believe plants and other organisms have group consciousness, but that's a different story and a different discussion. And then, once that gap goes above that evolutionary gap, then things start to go backwards and you have real consciousness the way we understand it, because this backward causation happens. And this clearly shows why and how consciousness emerges in animals. And back to the scallop. So coming to the question, are scallops conscious? So to do that, I looked at the scallop neural system. Scallops have something called ganglions. Ganglions are a collection of nerves that occur in those kind of animals, about 3 of them. The scallops are really unusual because all of those dots on scallops are actually eyes, and those eyes go to the certain kind of center that got quite a few neurons on it. But my personal feeling is that not enough neurons there to create a big enough gap between the processing and the input. So I feel much better now. I don't think scallops are conscious, but I think you have to go a bit higher. Bats are probably conscious, bats and rats, but it might be mice and those kind of things might be the lowest animals which have individual consciousness, based on this theory. I'm sorry, I'm doing it really fast, so I hope it was clear. We can talk about a few things. If anyone wants to do it, we can do it afterwards. It's very nice that I'm saying that backward causation actually causes consciousness, but why? When I started this view, I changed my view while I've been doing it. As I understood that consciousness is very little information, and I thought about my own experiences and experiences with meditation, I realized that the meditation experience is very similar to this experience of having no information. And I'm kind of slightly moving into the view that the reason why this happens is a panpsychic reason and not a completely physicalist reason, which means I'm slowly moving to the view that backward causation element, I believe, somehow touches something that kind of yanks consciousness into the organism as opposed to any other mechanism. And the last point on artificial intelligence, Artificial intelligence is the brain. The brain calculates. It's the radar. Consciousness is the laser that goes around it. The brain is never going to be conscious without the kind of radar that goes around it and actually collect information. The same with artificial intelligence. It's going to be very intelligent, but it's never going to be conscious unless, in my view, it's going to be able to replicate the biological structure of the brain as opposed to the information structure of the brain, which I think gives us intelligence as opposed to consciousness. Okay, but that's, I'm done. This is really, really fast. I hope it kind of stuck. If anyone has any questions, or